All right, status students. So we didn't have a lesson yesterday, but this one is going to be decently long. There's a lot that needs to be written down on this one. So we're going to jump right in, and there will be an assignment on Kittim for you all to do. It's a separate worksheet from the problem set, so I will reference that as we get to it. Okay, so here we go. Okay, so in your notes, if you would go ahead and write down the title here. I'd start a new section or maybe even a new page because there's going to be a lot that we're writing here. And we just need to have those rules written down for transforming and combining random variables. So we've been finding the means and standard deviations of these random variables. But now we're going to be transforming and combining them. That's going to be the goal here for this lesson. Okay. So let's do a little recap of what that looks like. So if we go back here in chapter 2, we did our first transforming of data. That was when I said, okay, hey, let's take all of our heights and let's stand on a box that's 10 inches high. And we saw what happened when we added 10 inches to everybody's height. We said, okay, well now let's convert it from inches, or let's go from inches to centimeters. And we saw what effect that had when we did that. Then we standardized the data, which meant we subtracted values and then divided. So we went through all the order of operations with this. So we learned that adding and subtracting affected only the measures of center and location. It didn't change the shape. Then multiplying and dividing changed the center and spread, or excuse me, the center and location, but it also changed the spread. So these are those rules. Hopefully that's not too blurry and too far away that you don't remember what I'm talking about. But if you, maybe it'll jog your memory to be reminded, okay, we took our heights that we actually collected for the class, and then we we changed them, they transformed them, okay? So what I want you to do is start off your notes. At the top, you'll see I have written Jeep tours. So that's going to be sort of our example. So I want you to write that in your notes, Jeep tours. And then what I want you to do is I want you to write down this chart here. You don't have to draw a graph. That's just a visual for you, but draw this chart down. And what I'd like you to do is take a moment. You're going to need your calculator, your TI Inspire. Go ahead and find the mean and the standard deviation for this. So how we'll write that is mu of x, because this is our random variable x. X is we have Pete's Jeep Tours. Let me define this situation. It's a popular half-day trip in a tourist area. There must be at least 2 passengers, so that's why you see 2 here for the trip to run, and the vehicle will hold up to 6 passengers. Define x as the number of passengers on a randomly selected day. So we want to find the mean and the standard deviation. Okay, that's what we want to find. The mean is also known as our expected value. Okay, so we want to find all of that. Okay, so grab your calculator. I'm going to pause it, and I want you to try to find that. Okay, so you should have typed in your in this random variable into your calculator, like so. Then we want to do the menu 411. This is going to be x, and then we have to change our frequency list to p of x. Okay, so we get our mean of 3.75 and a standard deviation of we'll say 1.09. Okay, so this is what we get for our mean and standard deviation. Okay, that was last section. So we know how to do that. Now we're getting into sort of the application of this. If I want to figure out, okay, it says Pete charges $150 per passenger. The random variable C describes the amount Pete collects on a randomly selected day. So we have this chart here. So I'm going to have you go ahead and copy that into your notes. Let's write this down. So basically, we've transformed this data here to this, and you'll see what happened. Per passenger, $150 is being multiplied by the 2, by the 3, 4, 5. But you'll notice that the probabilities stay the same. All of these values change. Now we have this random variable C. So you'll notice that the shape, so here's another distribution, it looks the exact same, except the numbers have shifted. Okay, so now what I want you to do is I want you to find the mean and standard deviation of, or mean and standard deviation of this. So let's talk about how you could do that. So if you're on your Inspire here, we can actually, I think we did this before in here, so we could actually make another column, call it C, because that's what we're talking about, cost per passenger. Go to this gray box area here, and you can rewind this if you want to see it again. Hit equals, and we can do X times, well, how much are we charging per passenger? 150. Okay. Column reference. Yeah, column reference. That's what we want. That didn't work. Hold on. Let's try that again. Equals X times 1. I guess we want variable reference. Yeah, that's what we want. Okay, variable reference. So we have taken this column here with the 2 and we've multiplied them by 150. Now let's do another menu for 1. This is going to be C this time, and we're going to use the same probabilities because the probabilities didn't change. So now we have a new mean here and a new standard deviation. Okay. Let's check that out. Let's go back here. So yeah, we have these in here. All right, now it says compare the shape, center, and spread of the two probability distributions. So watch what happened here. The 3.75, this mean from the original distribution, we multiply that by 150, and look what it gets us. It gets us that 562.50. So we're seeing that multiplying by a random variable is going to multiply the mean to get the new one. Then we see the same trend happen with the standard deviation. So yes, that's going to be our rule for this. So let's go ahead. We're going to write down this rule here. Move my camera down. We're going to pause it. You'll be able to write this down. I know there's quite a bit there, but we need to have this in our notes. This is just our rules for multiplying, or this works also for division by a constant. Okay, so go ahead and get that written. Okay, continuing. We know that Pete's pure profit here, he's this is his gross amount here from carrying customers, so he's making some pretty good money here for this tour. But he has costs associated with actually doing this. So he has to, it costs him $100 per trip to buy permits, gas, and a ferry pass. The random variable V describes the profit Pete makes on a randomly selected day. Now you'll notice that it's $100 less per each value. So we want to find the mean and standard deviation for this. Again, you can see that the overall, my camera up here, the overall shape of these distributions still is remaining the same, and that's a big part of this transformation. They are staying the same on these. So go ahead and let's find the mean and standard deviation for this new value. Okay. So once again, we're going to be doing some more transformations in here. So what I need to do is I need to take the total cost for his passengers, or how much they're paying him, and we need to take away 100 because he has to pay that off, right? Like that's his flat rate for fees, permits, and ferry pass. So we're going to put V in here. We're going to go down and we're going to say that's equal to, we need C minus 100. And again, not column reference, variable reference. So we get that, this is exactly what was on the table there. By the way, you needed to have written that down. I'll go back and share that with you. Now we want to do another menu 411. And we're going to do V. The probabilities have never changed since we've done this. The only things that are changing are the values of that random variable. So here we go. We got 462.50. And then the standard deviation is actually the same as it was. So let's go back to this. Yeah, look at that. You'll see the main difference between these is $100, right? It's minus 100. But these never actually changed here. The 163.50, it's the same. That's because the subtraction and addition do not affect the standard deviation. We already talked about that when we were adding when we did our heights back with just basic transformations. So those rules still apply here. So the spread of the data did not get affected at all, okay, because there's no multiplier. All right, so make sure that you have this chart down here, V, written down. Let's go ahead and continue. Here are the addition and subtraction rules, and on these, the big note here is that it does not change the measures of spread, which is that range, IQR, standard deviation. It doesn't change the shape. So I'll give you a moment, pause here, and you're going to write all of this, okay? All right, now that you've gotten that written, this next slide here is, I'm not forcing you to write anything, but this is sort of a way to look at it from a function standpoint. If X is the random variable, here's the linear transformations of this variable. So multiplication would be B, A would be addition. So the mean is affected by both addition with the A value and multiplication. However, the standard deviation is only affected by multiplication. And you're multiplying, we can never have a negative standard deviation, so you always do absolute value of B. And I think that was shown on this slide here. We see that right there, okay? Okay. All right, so let's move on. That is transforming information. Let me go ahead and show you what I'm gonna be having you do for here. This is suggested. Okay. So this is an assignment that's going to be on Kidam. It's a similar process, just like we saw in the notes here. You are filling out these tables, doing the different transformations. It shouldn't take you too long to do this, but make sure you ask me questions if you have them for this, okay? Now we're going to get on to the next part. So in your notes, draw a line and say combining random variables. And in the problem set, you're actually going to have questions that involve this, okay? So here in a second, we're going to do a problem from the problem set. There's not a ton of questions that go over these transformations and combining, but these are important, okay? So my music is going crazy right now. We got the Christmas theme in the background. All right, so we're going to be talking about Pete's Jeep Tours again, okay? And we have we have the random variables here. We've already defined the number of passengers is X, okay? And then we have another, so this is Pete's Jeep Tours, and then we have another person named Erin, her adventures. And we have the number of her passengers, okay? And what we're going to be doing is we're going to try to combine them and see what should combined. Maybe these two people are working together, and we want to know what do they expect combined. That's the idea. So Pete has his little thing going, Erin has her little thing going. If they're in business together, they want to see, okay, what do we expect for both of them, okay? That's what we want to know, okay? So there's Pete's, here's Erin's. So let's go ahead and draw down Erin's distribution here. Go ahead and write all these statistics down. We already had Pete's, so you don't have to draw the top one, but let's get this bottom one here. Now, obviously, you can see that the shapes are going to be different for these distributions here, okay? And what we want to do is we want to add these together. That's what we want to do, okay? So in order for us to add these together, here come the rules, combining these random variables. All we have to do for the mean, so you're going to write this, for the mean of the sum of random variables, we are going to add them together, okay? So what that means, going back to this, I'll have you write that in a second, we're just going to add this, and that gets us the new mean. That's a pretty straightforward process, I believe. So combined, they expect to get 6.85 passengers. That's their expected amount on a daily basis for for per trip. That's what they expect combined together. So that's a pretty simple process for finding that. Okay. Now, if you have multiple random variables, you're just going to sum all of their means. So that's that last sentence here. But I'm going to go ahead and pause this. You make sure that you get this written. All right, so you've got that written. Make sure also that you have the combined totals for the trip here. We just added those together. So you have mu of x plus mu of y is equal to 6.85. So that's mu of t, or the expected value of t. All right, cool. Now, what about the standard deviations? That's what we want to know. Well, actually, we need to write down a rule first, sorry. So we've talked a lot about independence in the probability unit, and we want to write just this one statement here. The only way to determine the probability for any value t is if x and y are independent random variables. So we should at this point know what independent means. It's restated here. And it says, if knowing whether any event X alone has occurred tells us nothing about the occurrence of any event involving Y alone and vice versa, then they are independent. So does knowing Pete's amount of customers affect the occurrence or tell us something about the occurrence of Aaron's, or vice versa? We should assume no. Therefore, they're independent. But that's going to be important for just this idea of independence. We said I said last chapter, once I introduce independence, we're going to keep using it for the rest of this year. Okay. Probability models often assume independence when the random variable describes outcomes that appear unrelated to each other. Our Jeep tours, right? Okay. Alrighty. Okay, and they operate. So these people operate at different parts of the country. All right. So we're going to. This is talking about standard deviation. They combined here the total. You can see that distribution is a lot different than what it was originally. Let me go back to it. The two separate ones. Move my camera. Here they are separate right here. When they get combined, we see that what that new distribution looks like. Okay, so they're going through all the process here of adding them together. It shows the possible combinations. We don't really have to worry about that too much. So we're going to talk about standard deviation. Okay, so how we find the sum of random variables standard deviations is for any two independent random variables, we get this formula for variance. Now, we don't really use variance that much. We talk about it. We need to understand that it's the standard deviation squared. And the reason we write it like this is so that when we're doing these calculations, we have to remember we have to square these standard deviations. Okay? So here is the formula that I actually want you to write, right here. Bottom one. You'll write both, but pure standard deviation is going to equal this. We have to take the square root of the first random variable squared plus the second random variable squared. If we had multiple random variables, we would have to square all of them and find that square root. Okay? So you can't just add the standard deviations. It's not like mean. You have to add their variances. Okay? If they're independent. So let's see what that looks like for this right here. Okay. So if I'm working this question, let me, actually I should move this to the other side. What? Here. It's in the way. Okay. So if I'm going to do my calculation here with this, I know that I need the square root of 1.09 squared plus 0.943 squared. This is the formula that we just wrote down right here. Okay, so this formula here that I'm waving around, that's going to find us the new standard deviation for this combined distribution. So we hit enter. That should be our new standard deviation, and I believe that's what they found. Well, they found their two standard deviations, but they needed to combine those. Did they do that here? They actually don't show that. So, but that is how you're going to want to find the combined random variable standard deviation. Okay, that's the rule for it. All right, cool. So we have that. Now we're going to write down one more slide here that we're going to write, and it's going to talk about. Oh, okay. So this is going to talk about. Already seen all this. Going to be about the mean of the difference. So if I'm subtracting two random variables, if they're being subtracted, we have to just subtract them in the appropriate order. Remember, order does matter for this. Okay, it says order of subtraction is important. So which one is actually being subtracted? So that would be the difference. You'll write that in your notes. And then the variance for the difference. So if I'm subtracting them, it's still going to be the same formula that we just saw. Okay, so I'm going to pause. You're going to write all this for me. Okay, and so that's all we need for our notes. Now we're going to do an example from the problem set to finish this lesson up. So we're 21 minutes in. That's actually shorter than I thought it would be. There's only a few questions that involve the sum or any transformations to these. So that's 22 through 27. Okay, so my main goal here is after we get back from Christmas break, because I think next week we're just going to talk probability. I may go into some of this down here, but I'm thinking I'm going to wait because I'm not trying to do too much next week. But you should be able to answer through 27 at this point, given all the lessons. I'm going to find us a question to work as an example, applying this knowledge that we just wrote in our notes. So let's go ahead and use that information. Second. All right, so let's do this problem. So we have this game invented by Albert. And it shows the X is the roll of the first die, Y is the roll of the second die, and it shows the probabilities. Z is the sum of the two dice. So we know that if we're trying to find the expected value of Z, then that's the mean, right? That's what we're trying to find. And we have our rule that we just wrote down for finding the mean of combining these random variables. If it's the sum, then we're going to add them together, right? So we're using this rule here, okay? I'm even going to copy that in here just so that we have it. Can refer to it. So let's do that. Paste, edit, paste. Okay. So this is going to be our rule. So what we're going to be doing is we're going to take 3.6, which is this mean, plus 8.0, which is the other mean. So combined is going to equal our expected value for T, which is what we want. Or excuse me, Z in this case. Whoops, Z. Okay. Bad. Let me fix that. There we go. Okay. So when we add those, we're going to get 11.6, and that's how we're going to answer this. So that's the combined sum there. Okay. Let's copy the next question because we're going to need that. So we need what is the standard deviation? Okay. See, again, we're adding these variables together. Let me paste again. Okay, what's the standard deviation of Z? Well, let's go back to our notes. How do you find standard deviation? Well, we have this nifty formula here. We need to square the standard deviations, and then add them together after squaring, and then we square root them. So this, what we actually have is sigma of Z is equal to, we want to raise this 0.8, and we want to the second power. Then we want to add that to, we have 0.9. We're going to square that. Let's see what we get there when we do that. So we're going to, I'm just going to copy what I had up here and just change the numbers. That was 0.9. 0.8, hit enter. So we get 1.204. I'm pretty sure it's going to round it. And we'll round down, so A should be the best answer on that. Good, good, good. Now what it wants to know is, I think we're going to do a transformation on this. Let's see. It says, Albert's game, you give him $10 each time you roll. He pays you in dollars the amount that comes up on the die. If P is the amount of money you gain each time you roll, the mean and standard deviation are. Okay. So we're going to do a linear transformation on this. So we have our combined amounts here and here. So for Z, let me go down. So the mean of Z, that's standard deviation. Let me actually just copy this in here. So we know that our mean of Z is 11.6. Okay. And then our standard deviation is, we had 1.2. So each time we roll, we're interested in how much we gain when we do this. So each time we play, we're losing $10. So what we need to do is we're going to subtract $10 from every outcome, because he's going to give back what comes out on the dice. And if we expect 11.6 to occur, like that's what we expect. We expect to get $11.6 from him every time after we've paid $10. We're going to subtract 10 from that. So the mean of P should equal $1.6. That's how much we should expect. Now, with subtraction, we talked about our rule for subtraction. Remember that this is a linear transformation. For subtracting, it does not change the measures of spread. Therefore, on this problem, standard deviation is actually going to stay exactly the same. We don't subtract 10 from that. Okay, so that's important. So we're looking for this one. It looks like C is going to be the best answer for us on this one. Okay. All right, so that's going to be our lesson for today. You've got a sheet that's going on Kitum that you need to do for linear transformations of these things, and then you've got one more question on here to work for combining these random variables. Okay, I might get some more practice out for this, especially next semester when we have to come back and review it. So just be prepared for that. And as always, if you have questions, reach out to me.